explain about problems with Rutherford atomic model. It is also called as drawbacks of the Rutherford atomic model. So, the scientist Rutherford, he explained about the model of an atom. So, what are the problems with his atomic model? Otherwise, we called what are the drawbacks of his atomic model? The first drawback is said to be instability of the atom. Instability of the atom. So, what is the instability of the atom? So, what are the points that we are observed in the instability of the atom? So, according to Rutherford, he is telling that the entire mass of the atom is concentrated at its center, and it is in a small place. That a small place at the exactly center of the atom is called the nucleus. So the nucleus, which consists of positively charged protons, and also we have neutral particles called as neutrons. So that is what we call, it's called the nucleus. The dimension of the nucleus is found to be about 10 to the power of minus 15 meters. Based on these concepts, he explains clearly about the model of an atom. So, there will be whenever the alpha particles bombard with that an atom, then there will be a scattering angle is there. That scattering angle is too high. It means that there will be large angle of scattering of alpha particles. And the second point is the electrons revolves around the nucleus in the circular orbits of all possible radius. And there will be an electrostatic force of attraction takes place. That electrostatic force of attraction means there will be a positively charged protons in the nucleus, and in the outside orbits there will be electrons. Since electrons are said to be negatively charged, protons are said to be positively charged, so there will be a unlike charges. Whenever there will be an unlike charges means there will be attraction takes place. That attraction is called as a force of attraction. It means that it is called as electrostatic force of attraction. This electrostatic force of attraction, which gives us the centripetal force for an atom. It means that the electrostatic force of attraction, which provides the centripetal force. So these are the expressions of an atom according to Rutherford. It means that there will be a large angle of scattering of alpha particles. The electrons will revolve around the nucleus in the circular orbits in all possible radii. The electrostatic force of attraction, which gives us centripetal force. Now, this atomic model means Rutherford atomic model, which fails to explain the classical electrodynamics principle, according to which an electron should give out energy continuously. So whenever the electrons which are moving, it gets accelerated, means its velocity goes on increasing. So whenever the velocity of the electron which goes on increasing means that is called as accelerated electrons. These accelerated electrons which gives out energy continuously. When the electrons revolves around the nucleus, it is subjected to a centripetal acceleration. It is subjected to a centripetal acceleration means the electrons which are moving towards the center, toward the center of the an atom. So, because by means of centripetal acceleration, and hence it gives out energy which it is taken from the atomic system itself. Now, it means that electron cannot revolve in a circular path. ಯಾವಾಗ electrons nucleus in the madhya bidutte fall agutte anta helta idano, it means that electrons cannot revolve in a circular orbit. Electrons can move in a spiral path. So ಆಚೆ ಕಡೆ ಎಲ್ಲ ಒಂದು ಕಡೆ ಇದೆ, ನಾನು ಲಾಸ್ಟ್ ಕ್ಲಾಸ್ ಅಲ್ಲಿ ಎಕ್ಸ್ಪ್ಲೈನ್ ಮಾಡಿದಂಗೆ. ಸೊ ಈಗ ಸುತ್ತುತ್ತಾ ಅದು ಒಳಗಡೆ ಬರ್ತಾ ಇದೆ. ಸೊ ಫೈನಲಿ ಮಧ್ಯ ನ್ಯೂಕ್ಲಿಯಸ್ಗೆ ಬಿದ್ದುಬಿಡುತ್ತೆ. That is called as spiral path. The electrons cannot revolve in the circular path, but it describes a spiral path of decreasing radius. So ಯಾವಾಗ ಸುತ್ತುತ್ತಾ ಒಳಗಡೆ ಬರ್ತಿದೆಯೋ ರೇಡಿಯಸ್ ಕಡಿಮೆ ಆಗ್ತಾ ಇದೆ, ಕಡಿಮೆ ಆಗದೆ ಫೈನಲ್ ಆಗಿ ಇಟ್ ವಿಲ್ ಬಿ ನಲ್ ಆಗುತ್ತೆ ಅಂದ್ರೆ ಬಂದು ನ್ಯೂಕ್ಲಿಯಸ್ಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. So we have ultimately it can fall into the nucleus. Thus this model had neither stability nor capable of explaining the origin of the spectral lines. Now, the instability of an atom can also be explained by means of another one experiment. Let us take one atom. So this atom with two electrons, atoms with the two electrons. Let us imagine we have atoms with the two electrons. Means imagine we have, this is called as an atom. This is an atom. So atom this is called as a nucleus. This nucleus is here. Orbit. Let us imagine this is one orbit. This is one another orbit. It should be like this. So let us keep one electron is here. The electron is so the electron electron. So this is an atom having two electrons. So now ಇಲ್ಲಿಂದ ಏನು ಡಿಸ್ಟೆನ್ಸ್ ಇದೆಯೋ ಇಲ್ಲಿಂದ same distance ಇದೆ. It means that let us place two electrons at the same distances on either side from the nucleus. Since this is a negative charge, this is a positive charge, this is a negative, we have a negative charge. So there will be a force exist between this negative to positive called as force of attraction. We call this called as force of attraction. So we call this is called as electrostatic force of attraction. Electrostatic force of attraction. Since this is a negative because these four electrons, so there will be another force exists. That force is called as force of repulsion. Force of repulsion. So this is called as electrostatic force of repulsion. Electrostatic force of repulsion. So if we calculate the force of attraction and the force of repulsion, then the force of attraction between the nucleus and the electron is given by 2e squared divided by r squared. 2e squared divided by r squared. This is the force of attraction between the nucleus and the electron. So now the force of repulsion between the electron and electron is given by e squared divided by 4r squared. So e squared divided by 4r squared is called as the force of repulsion between the electron and the electron. So force of attraction between the photons and electron is given by 2e squared divided by r squared. Since these two are not equal, it means that the force of attraction is 8 times that of force of repulsion. So force of attraction, force of repulsion 8 times ಜಾಸ್ತಿ ಇದೆ. ಈಗ 2e squared divided by r squared e squared divided by 4r squared ನೋಡಿದಾಗ, ಸೊ ಇದಕ್ಕಿಂತ ಇದು 8 ಟೈಮ್ಸ್ ಜಾಸ್ತಿ ಇದೆ. It means that this is E squared by R squared. 4 into 2, 8. So like that, the force of attraction is 8 times greater than that of the force of repulsion. So whenever the force of attraction is 8 times greater than that of the force of repulsion, then there will be no equilibrium. No equilibrium at all. ಅಲ್ಲಿಗೆ ನಾವು ಇಲ್ಲಿ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಇಲ್ಲ ಅಂದಂಗಾಯ್ತು. ಸೊ ಯಾವಾಗ ನಮಗೆ ಈಕ್ವಿಲಿಬ್ರಿಯಮ್ ಇಲ್ಲ ಅಂತ ಹೇಳ್ತಾ ಇದೀವೋ ಅಲ್ಲಿಗೆ ಸೊ there will be no stability. Stability ಅನ್ನೋದು ನಾವು ಹೇಳಲಿಕ್ಕೆ ಆಗೋದಿಲ್ಲ. It means that you have to say that equilibrium cannot be secured with the electrostatic forces. So like that, if we consider an atom with 2 electrons having the charge plus 2e symmetrically placed on either side, symmetrically placed at a distance smaller from the nucleus. ಅಂದ್ರೆ ಆ ನ್ಯೂಕ್ಲಿಯಸ್ ಇಂದ ಅಕ್ಕಪಕ್ಕ ಈಕ್ವಲ್ ಡಿಸ್ಟೆನ್ಸ್ ಅಲ್ಲಿ ನಾವು ಇಟ್ಟಿದೀವಿ ಅಂತ. Then ನಾವು ಕ್ಯಾಲ್ಕುಲೇಷನ್ ಮಾಡಿದಾಗ force of attraction between the nucleus and the electron calculation ಮಾಡಿದಾಗ it will be found that 2e squared divided by r squared. At the same time, if we calculate the force of repulsion between the electrons, then it will be found that e squared divided by 4r squared. It means that force of attraction is 8 times greater than that of the force of repulsion. Hence, condition of stability is not satisfied. So ಹಾಗಾಗಿ ಆ stability condition satisfy ಆಗಿಲ್ಲ. So ಅಲ್ಲಿಗೆ ಏನಾಯ್ತು ಅಂದ್ರೆ there will be atom is unstable. But actually atom stable ಆಗ್ತಾ ಇದೆ. So ಇದನ್ನ ಓವರ್ಟೇಕ್ ಮಾಡಿ, ಇದನ್ನ ನಾವು ಸ್ವಲ್ಪ ಮಾಡಿಫೈಡ್ ಮಾಡಿ another one atomic model ಇದೆ, that is called as Bose atomic model. Then another scientist called as Niels Bohr. So Niels Bohr another scientist he gave one atomic model called as Niels Bohr's atomic model. So Niels Bohr he applied one quantization rule for this one. Quantization rule ಅನ್ನು ನಾವು ಅಪ್ಲೈ ಮಾಡಿದ್ದೇವೆ. By making use of his quantization rule, that Niels Bohr he found another one explanation for the atomic model, that is called as Bohr's atomic model. So Bohr's atomic model he successfully explained so many of the atomic phenomenon. Bohr's atomic model Bohr so satisfactorily explains so many atomic phenomenon. So what he assumed that so that to overcome the defects of Rutherford, that Niels Bohr he assumed some of the assumptions, the basic postulates of Bohr's theory is the combination of ideal classical physics. One ideal classical physics na avanu combination madidane, and also Planck's quantum. It's a combination of ideal classical physics and also quantum physics. So ee combination of classical physics ಮತ್ತೆ quantum mechanics avanu combination ಮಾಡಿ he gave his own ideas about the stability of the atom. Now according to quantum mechanics, the energy of a system, it is also called as the exchange of energy between different systems occurs not in a continuous fashion. So exchange of energy now continuous fashion alli agodilla, permitting all possible values and demanded by the classical physics. But in a discrete quantified form as integral multiples of elementary quantums, energy is called as h nu. So ಏನು ಒಂದು energy emission ಆಗ್ತಾ ಇದೆ, that energy is called as quanta, that is called as E equals h nu, in which h is called as Planck's constant, nu is called as frequency. So that Niels Bohr he built his own way that atomic structure on the following two fundamental postulates. ಅವಂದೇ ಆದ ಒಂದು ಫಂಡಮೆಂಟಲ್ ಪಾಸ್ಟುಲೇಟ್ಸ್. ಸೊ ಅದ್ರ ಮೇಲೆ ಅವನು ಆಟಮಿಕ್ ಸ್ಟೆಬಿಲಿಟಿ ಬಗ್ಗೆ ಅವನು ಹೇಳಿದಾನೆ. Now, what are those postulates? Postulates ಏನಂತಂದ್ರೆ, the first postulate is explaining about the electronic structure of the atom. Electronic structure of the atom. So, what that electronic structure? So, the difficulties faced by the Rutherford model, and it can be solved by Niels Bohr with his own postulates. The first postulate is given by the electrons can revolve. The electrons can revolve around the nucleus only in certain discrete orbits. So, ಅವನು ಹೇಳಿದ ಅಂದ್ರೆ the electron can revolve in all the possible radii ಅಂತ ಹೇಳಿದ, in all the possible orbits. But he is telling that so the electron cannot revolve in all the possible orbits, but electrons can revolve only in the certain ಕೆಲವೊಂದು ಅಂತ. So only some certain discrete orbits called as stationary orbits. Only in permitted orbits only the electrons can move. So ಎಲ್ಲ orbits ಗಳನ್ನ ಬದಲಿಗೆ only ಕೆಲವೊಂದು permitted orbits ಮಾತ್ರ electrons nucleus ಅನ್ನು ಸುತ್ತುತ್ತಾ ಇದೆ. That is about the electronic structure. And the second is whenever the electrons which are moving in a circular path, there will be a angular momentum can also be comes into existence. ಅಲ್ಲಿ ಒಂದು angular momentum ಕೂಡ ಪಿಕ್ಚರ್ ನಲ್ಲಿ ಬಂದ್ಬಿಡುತ್ತೆ. ಯಾಕೆಂದ್ರೆ ಯಾವುದೇ ಒಂದು ಬಾಡಿ ಸರ್ಕ್ಯುಲರ್ ಮೋಷನ್ ಹೋಗ್ತಿದ್ದಾಗ so there will be momentum, and whenever momentum ಅನ್ನೋದು whenever a body which is moving in a straight path, so the same body which is moving in a circular path, there is an angle is formed. That's why it's called as an angular momentum. So illu kuda angular momentum of the electron can also comes into existence. Now that angular momentum of the electron is quantized. Avanu quantized anta helta idane, and it is nothing but it's an integral multiple of h by 2 pi. So the angular momentum is quantized and it is equal to an integral multiple of h by 2 pi. This is the second postulate of Niels Bohr about his atomic model. The first postulate and the electron can revolve only in the permitted orbits. So that is called as stationary orbits. So that is called as the first postulate. The second postulate is given by the angular momentum of the electron is quantized and it is an integral multiple of h by 2 pi, where h is called as the Planck's constant. ಒಂದು ವೇಳೆ whenever the electrons which are revolving in the nth orbit, so nucleus ನ ಪಕ್ಕದಲ್ಲಿ ಇರೋದು ಫಸ್ಟ್ ಆಗ್ಬಿಟ್ಟು ಸೆಕೆಂಡ್ ಇರೋದು ಸೆಕೆಂಡ್ ಆಗ್ಬಿಟ್ಟು ಹಾಗೆ ಹೋಗ್ತಾ ಹೋಗ್ತಾ let it be it is revolving in the nth orbit, then whenever if the electrons which are moving in the nth orbit, then its angular momentum is given by nh by 2 pi. So it is integral multiple of h by 2 pi ಅಂತ ಹೇಳ್ತಿದೀವಿ. ಸೊ ಯಾವ ಎಲೆಕ್ಟ್ರಾನ್ ಯಾವುದೇ ಆರ್ಬಿಟ್ ಅಲ್ಲಿ ನಾವು ಮೂವ್ ಮಾಡ್ತಾ ಇದೆ ಅಂದಾಗ ನಾವು nh by 2 pi. So n gives the value 1 2 3 4 5 like this. So whenever that electron which is moving in the first orbit, the value of n is equal to 1, then the angular momentum is given by h by 2 pi. Okay, ಒಂದು ವೇಳೆ electron which are moving in the second orbit ಅಂದಾಗ the value of n is equal to 2, then we have to say that it is called as 2h by 2 pi. ಒಂದು ವೇಳೆ electron third orbital move ಆಗ್ತಾ ಇದೆ ಅಂದಾಗ ಆವಾಗ that angular momentum is given by 3h by 2 pi. In standard equation is given by the angular momentum is given by nh by 2 pi. The value can take the value n is equal to 1 2 3 up to n. So this is called as Bohr's quantum condition. ಏನು ಇದು ಇದೆಯಲ್ಲ ಈ ಒಂದು nh by angular momentum is equal to nh by 2 pi ಅನ್ನೋದು, that is called as Bohr's quantum condition. This is called as a Bohr's quantum condition. Then so whenever that energy is supplied to an atom, ಯಾವಾಗ ಎನರ್ಜಿ ಸಪ್ಲೈ ಆಗುತ್ತೋ ಆಟಮ್ಗೆ, then electrons jumps from higher energy level to your lower energy level. The electrons can jump from higher energy level to lower energy level and comes back to its normal state. So ಏನು higher level ಇಂದ lower level ಗೆ ಜಂಪ್ ಹೊಡಿತೆ, so ಆ ಮೂಲಕ ಅದು ನಾರ್ಮಲ್ ಸ್ಟೇಟ್ ಗೆ ಬಂದ್ಬಿಡುತ್ತೆ. So the energy, the difference in the energies of electrons emitted as quantum of radiation. So ಅವಾಗ ಹೇಳ್ದಂಗೆ ಅದು ಎನರ್ಜಿ ಎಮಿಷನ್ ಆಗ್ತಾ ಇದೆ, that energy is equal to h nu. So ಹೇಗೆ ಅಂದ್ರೆ suppose let us imagine whenever the electron is present in the second orbit, we call that energy of the electron in the second orbit is found to be E2. Whenever that electron is present in the first orbit, the energy of the electron in the first orbit is found to be E1. Then E2 minus E1 is given as h nu. So E2 minus E1 is given as h nu. It means that we have to say that, imagine we have these are the different electrons. So imagine this is called as the first orbit, n is equal to 1. This is called as the second orbit, n is equal to 2. The energy corresponding to the first orbit, we call this is called as E1. The energy corresponding to the second orbit, we call this is called as E2. So the electron in the atom, the energy is supplied because of that energy. Some of the electrons present in the second orbit. The second orbital is the so this second orbital is the electron which jumps from the second orbit to first orbit. The energy can jump from second orbit to first orbit. Whenever these electrons which are jumping from second orbit to third orbit, then it can emit some energy. That is given by first it is in the second state, then it is coming in first state. That's why we have E2 minus E1, that is given by h nu. This is the energy emitted by the electron while jumping from the higher orbit to lower orbit. So E2 minus E1 is equal to h nu. The nu is called as that frequency, h is called as Planck's constant. So like this, there will be a emission of that energy can take place whenever there will be a transferring of electrons from one orbit to second orbit. So like that, when the energy, the electrons jumps to higher energy level and comes to its normal state, the difference in the energies emitted as quantum. So that is E2 minus E1 is equal to h nu, where nu is called as frequency of emitted energy. Okay. Now this is known as that Bose frequency condition. Second postulate that is called as Bose quantum condition. The second postulate Bose quantum condition. Now the third postulate is given by Bose frequency condition. Now Bose frequency condition ಅಂತ ನಾವು ಹೇಳ್ತೀವಿ. So here E1 and E2 are the initial and final energies of the electron. So E1 ಮತ್ತು E2 initial ಮತ್ತು final energies of the electron. So the radius of the electron in the nth orbit of the hydrogen-like atoms is given by, so small r is equal to n squared h squared epsilon naught divided by pi m z e squared. ಇವೆಲ್ಲ ಸೆಕೆಂಡ್ ಪಿ ಯು ಸಿ ನಿಮಗೆಲ್ಲ ಇತ್ತು. ಸೊ ಇಟ್ ಇಸ್ ಗಿವನ್ ಬೈ ಸೆಕೆಂಡ್ ಪಿ ಯು ಸಿ ಇತ್ತಲ್ವ ನಿಮಗೆಲ್ಲ. ಸೊ ಇದನ್ನ ಬೇಕಾದ್ರೆ ಸಲ ಮಾಡೋಣ ನಾವು, ಬಿಕಾಸ್ ಇದನ್ನು ಕೂಡ ಕೇಳ್ಬೋದು. ಸೊ ಲೆಟ್ ಅಸ್ ಸಿ ಇನ್ ದಿಸ್ okay. Now the radius of the electron in the nth orbit, the radius of the electron in the nth orbit of hydrogen-like atoms. This is only for the hydrogen-like atoms. So hydrogen-like atoms is given by oil. So is given by n square h square epsilon naught divided by pi m z e square. So here all of the radius of the electron n thought is given by n square h square epsilon naught pi m z e square. So here it is said to be, so ಯಾವ ಆರ್ಬಿಟಲ್ಲಿ electron ಇದೆ ಅಂತ. If it is the first orbit, we take n is equal to 1. If it is the second orbit, if you take n is equal to 2, and h is Planck's constant, so epsilon naught is permittivity of free space, and we have a phase constant. And this part has mass of the electron That is called as atomic number of the substance. What metal is called as sound of the electron. So like this, R is equal to n squared epsilon naught by m z is squared. So like that, similarly, the velocity is given by the velocity of the electron in the nth orbit. The velocity of the electron in the nth orbit is given by Dn is equal to z e squared divided by 2 n h epsilon naught. So this is called as velocity of the electron in nth orbit. Similarly, z is there, e there, 2 n h epsilon naught. So these are the radius and the velocities of the electron in the different orbits. Now we have to find that energy levels of hydrogen. So this is about the radius and also velocity. Let us consider this as the energy levels of hydrogen like atoms. And the spectrum. So let us see what are the energy levels. And here we have the energy of the electron. The energy of the electron is the sum of kinetic energy and potential energy. The energy of the electron is given by the sum of kinetic energy and the potential energy. So ಯಾವುದೇ ಒಂದು ವಸ್ತು ತಗೊಂಡಾಗ ನಾವು the energies can be classified into two types. One is called as kinetic and also potential. Kinetic energy means it is the amount of work done. It is the capacity of doing work by the virtue of its motion. So potential energy means it is the capacity of doing work by the virtue of its position. So ಎರಡು energies ಕೂಡಿದಾಗ ನಮಗೆ total energy ಆಗುತ್ತೆ. So we call the total energy is given by E is equal to the sum of kinetic energy and potential energy. So we have total energy is given by kinetic energy and potential energy. Now kinetic energy is given by half mv squared. So this is the basic formula. Kinetic energy is given by half mv squared. Then it is given by 1/8 epsilon naught z e squared divided by r. So ಅದನ್ನ ಮಾಸ್ ಮತ್ತು ವೆಲಾಸಿಟಿ ನಾವು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ ನಮಗೆ kinetic energy is given by 1/8 epsilon naught z e squared divided by r. So next potential energy is given by minus 1/4 epsilon naught z e squared divided by r. This is called as potential energy. So in the expression for the kinetic energy, potential energy and loss of total energy that you have studied in the second PUC level level put there. So once again just we have arranged like this. ಇದನ್ನೇ ನಾವು ಪ್ರೂವ್ ಮಾಡೋ ಅವಶ್ಯಕತೆ ಇಲ್ಲ. So kinetic energy is given by 1/8 epsilon z e squared by r ಅಂತ ಹೇಳ್ಬೋದು. ಹಾಗೆ potential energy is equal to minus 1/4 epsilon naught z e squared by r straight away I have put in the examination. Now we know that kinetic energy and also potential energy. Kinetic energy ಏನಿದೆ ಈ ವ್ಯಾಲ್ಯೂನ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು, potential energy ಇದೆ ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಬೇಕು. So ಎರಡು ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡಿದಾಗ we will get the final equation that is given by E is equal to now this that E is given by 1/8 epsilon naught 1/8 epsilon naught z e squared by r. So this is kinetic energy ನಾವು ಇಲ್ಲಿ ಸಬ್ಸ್ಟಿಟ್ಯೂಟ್ ಮಾಡ್ತೀವಿ. So plus potential energy is given by minus, that's why I put minus 1/4 epsilon naught z is squared divided by potential energy. So this is the total energy of the electron, kinetic energy plus potential energy. ಇಲ್ಲಿ ನಮಗೆ z is squared r ಕಾಮನ್ ಆಗಿ ಹಾಗೆ 1/4 epsilon naught 1/4 epsilon naught ಇದೆ. So ಎಲ್ಲ ನಾವು ಕಾಮನ್ ಆಗಿ ಚಿತ್ರ ತೆಗೆದುಕೊಳ್ಳೋಣ. If you take it as a common factor, then E is given by 1/4 epsilon naught z ಇದನ್ನು ನಾವು ಸಿಂಪ್ಲಿಫೈ ಮಾಡುವಾಗ E is given by minus Z E squared divided by 8 pi epsilon naught of the negative side. Because half minus 1 is minus half ಇದು ಗೊತ್ತಾನೆ half minus 1 is minus half minus into 1 so 2 into 4 8 ಆಗ್ತಾ ಇದೆ ಇದು ಮಾಮೂಲಿ as it is here z is divided by 4.0 but here this is for as r is for as radius of the electron so ನಮಗೆ radius of the electron ಗೊತ್ತಿದೆ ಅಲ್ವಾ so now we have to substitute out this radius of the electron ಈ radius of the electron ನಾವು substitute ಮಾಡಿದಾಗ but you know that r is given by that the small r is given by n squared epsilon naught n squared epsilon naught pi m z e squared pi m z e squared pi m z e squared so after substituting this value in this equation ಅಲ್ಲಿ r value complete substitution ಮಾಡುತ್ತೆ finally we got that energy is given by energy in the unit object is given by minus m z square e to the power 4 minus m z square e to the power 4 divided by 8 epsilon naught square n square x square n square x square. So this is energy of the tensor like atoms. And then here small organ ಇದೆಲ್ಲ substitution ಮಾಡಿದಾಗ so finally ನಮಗೆ ಬಂದಿದ್ದು E is equal to minus m z square e to the power 4 divided by 8 epsilon naught square n square h square. So ಇದನ್ನ ನಾವೆಲ್ಲ ನೋಡಿದಾಗ we got one minus sign here ಹೌದಲ್ವಾ so En ಅಂದ್ರೆ energy of the electron in the nth orbit. Energy of the electron in the nth orbit that is given by En is given by minus m z squared e to the power 4 divided by 8 epsilon naught squared n squared h squared. See now this negative sign shows that electrons are always bound to the nucleus. ಆ ನೆಗೆಟಿವ್ ಸೈನ್ ನಮ್ಗೆ ಏನಪ್ಪ ಹೇಳ್ತಿದೆ ಅಂತಂದ್ರೆ ಯಾವತ್ತೂ ಕೂಡ ಎಲೆಕ್ಟ್ರಾನ್ಸ್ ನ್ಯೂಕ್ಲಿಯಸ್ ಗೆ ಬೌಂಡ್ ಆಗಿದೆ ಅನ್ನೋದು ಮೀನಿಂಗ್ ನಮ್ಗೆ ಹೇಳ್ತಾ ಇದೆ so we call that electron is always bound to the nucleus because we got that negative sign in the energy of the nth electron. So like this the energy is given by En is equal to minus m z squared e to the power 4 by 8 epsilon naught squared n squared h squared means we have negative sign which indicates that electrons are always bound to the nucleus. Now let us, if we calculate that energy for singly ionized atom, the energy for the singly ionized atom, in such a case we have the value of Z is equal to 2 ಆಗುತ್ತೆ. For singly ionized atom, the value of Z is equal to 2, then it is given by Z squared ಅಂದ್ರೆ ನಮಗೆ 2 squared means 4 ಆಗುತ್ತೆ. ಆ ನ್ಯೂಮರೇಟರ್ ಅಲ್ಲಿ 4 ಇದೆ ಕೆಳಗಡೆ 8 ಇದೆ ಸೊ ಅವಾಗ ಏನಾಗುತ್ತೆ ನಮಗೆ ಇಟ್ ಇಸ್ ಗಿವನ್ ಬೈ ಬೋರ್ಡ್ ಕಾಣ್ತಿದ್ಯಾ ಇದು ಓಕೆ ಸೊ ಫಾರ್ ಸಿಂಗ್ಲಿ ಹೈಡ್ರೋಜನ್ ಆಟಮ್ we have the value of Z is equal to 2. Whenever the value of Z is equal to 2, then we will have ಅಂತಲ್ವಾ so now whenever Z is equal to 2, then we will have that En is equal to minus m. The value of Z is equal to 2 means 2 into 2 we have 4 e to the power 4 divided by 8 epsilon naught square h square h square. So we have En is equal to minus m e to the power 4 divided by so the 2 is equal to 2 into epsilon square h square h square. So this is for a singly hydrogen atom. Energy for the singly hydrogen atom En is equal to minus m e to the power 4 divided by n square 2 n square epsilon naught square n square h square. So now we have to calculate the wave number of these spectral lines. Now the wave number of the spectral lines is given by the wave number of the spectral lines is given by, so we'll have the wave number means we have what is the equation for the wave number, the explanation, the definition for the wave number. Wave number again ಗೊತ್ತಿದ್ಯಾ definition? The total number of spectral lines present in the spectrum, that is called as a wave number, isn't it? The wave number of the spectral lines is given by the formula nu bar is equal to 1 by lambda. Nu bar is equal to 1 by lambda. So 1 by lambda, it gives us wave number. It is given by m z square e to the power 4 by 8 epsilon naught square ch cube into 1 divided by n1 squared minus 1 divided by n2 squared. Okay. Kuchila ido? Okay, let us see now. So, the wave number of the spectral line is given by the wave number of the spectral line is given by nu bar is equal to 1 by lambda. Nu bar is equal to 1 by lambda. That is given by m z square e to the power 4 divided by 8 epsilon naught square ch cube into 1 divided by n1 square minus 1 divided by n2 square. So this is called as a wave number. So now nu bar is equal to capital R z square into 1 by n1 square minus 1 by n2 square. So this z square is there. If I capital R is there, so that R is equal to m e to the power 4 divided by 8 epsilon naught square ch2, that is called as vertical constant. Vertical constant. So m e to the power 4 divided by 8 epsilon naught square ch2 is there. Capital R is this capital R is called as vertical constant. So 1 by n1 square minus 1 by n2 square. So this is called as expression for the wave number. Okay. So like this, we have to found that radius, velocity, and also wave number of the hydrogen-like atoms. So next, in the next class, we have to discuss about the energy level diagrams. Energy level diagram ಬಗ್ಗೆ next class ಅಲ್ಲಿ, so we have to discuss. Okay.